Okay guys, today we're going to continue our solving of trigonometry part 2. We're now in number 9. Find the smallest positive coterminal of negative 390 degrees. Our solution, we're going to write first negative 390 degrees. Then we're going to add plus 360 degrees. Because we're going to add 360 degrees because in one rotation in a circle is equivalent to 360 degrees. Then we're going to add, since unlike sign, we're going to minus, and the result is negative 30 degrees. And then, since we're looking for the smallest positive, we're going to add 360 degrees. Then we are going to minus the negative 30 degrees, and the result is 330 degrees. This will be the smallest positive numbers from negative 390 degrees. Next, number 10, find the smallest positive coterminal of 40 degrees. Our solution, the smallest positive of 40 degrees, we're going to add 360 degrees. Again, 360 degrees, this is the one rotation in a circle. And then if we're going to add, the result is 400 degrees. Since this is the first positive result from 40 degrees, so this will be the smallest positive coterminal of 40 degrees. Next, number 11. Find the smallest positive and biggest negative coterminal of 1000 degrees. Our solution for the small positive, from 1000 we're going to add the one rotation in a circle. We have 360 degrees and the result is 1360 degrees. This will be the smallest positive coterminal of 1000 because this is the first positive result when we add 1360 degrees. For the smallest, biggest negative coterminal, from 1000 we're going to minus 360 degrees. This 360 degrees came from one rotation of a circle. It is equivalent to 640 degrees positive. Then again, we're going to minus 360 degrees, and the result is positive 280 degrees. Then again, we're going to minus 360 degrees, and the result is negative 80 degrees. This will be the first biggest negative result coterminal of 1000. This will be our answer. Okay, next, number 12. Identify the region measures of two counterclockwise revolutions. Okay, our solution, we have to remember that in one revolution we have 2 phi. Since 2 counterclockwise means to say we have 2 revolutions, that's why we're going to multiply 2 pi by 2. And the result is 4 pi. So 4 pi region now is the equivalent of 2 counterclockwise revolution. Region is the unit for pi. Next, number 13. What is the region measure of 3/4 revolution? Our solution, 2 pi times 3/4. So we have to multiply 2 times 3 equals 6, copy phi. Then copy denominator. Then we're going to simplify the 6 pi over 4. So we're going to think for the greatest common factor, meaning to say we're going to take a number, the greatest number that we can divide the numerator and denominator. So that's why our answer is 2. 6 divided by 2 equals 3 pi. Then 4 divided by 2 is 2. So our answer is 3 pi over 2 region. Okay, number 14. Convert 90 degrees measure to region. Our solution, 90 degrees times pi over 180 degrees. So this will be our constant number to multiply 90 degrees times pi equals 90 degrees pi over 180. And we're going to simplify 90 divided by 90 equals to 1 times pi equals pi. 180 divided by 90 equals 2. That's why our answer is pi over 2 is to convert the 90 degrees measure to region. So remember, region is the unit measure for pi, and this pi is Greek letters. Okay, next, 15. Convert pi region measure to degree measure. So our solution, pi times 180 over 5. So it is now inverted. So reverse formula from our previous. So pi times 180 degrees equals 180 degrees pi over pi. And then we're going to cancel the pi. Then 1, 1. Then 180 times 1 equals 180. Then copy 1. The division 1. So simplify equals to 180 divided by 1 equals 180 degrees. This will be the answer. Next, number 16. Identify the region measures of 2 clockwise revolutions. Our solution again, in one revolution we have 2 pi times negative 2. If it's clockwise, 2 revolutions, it becomes negative 2. Then multiply 2 pi times negative 2 equals negative 4 pi region is our answer. Number 17, express 2 pi over 3 region to degree. Our solution, 2 pi over 3 times 180 degree over pi. Then 2 pi times 180 degrees equals 360 degrees. Then 3 times pi equals 3 pi. Then we're going to cancel the pi. Then 360 degrees divided by 3, we have 120 degrees. This will be our answer. Okay, next number 18. Find the 6 trigonometric functions using the figure. Remember the 6 trigonometric functions, we have sine, cosine, tangent, cosecant, secant, and cotangent. And from this figure, the given is the hypotenuse here is 9 to 10 units, and the movement of this angle from initial here from the x-axis going here, and this y-axis, and we have coordinate of 6 and 8. So first, our solution, we have to know the given y here. So this is the y. The ordinate is 8, and the x coordinate is 6, or the abscissa, and the hypotenuse is 10. So this is the given. Now our answers now for the 6 trigonometric functions, we have sine theta. So this theta means the angle from the origin here. So this is the angle, this is the theta. The theta is a Greek letter. Now, sine theta, our formula is opposite over hypotenuse. So, the opposite of this angle here, from this angle, from the theta, so this is the y. So, that's why we have y over the hypotenuse here is this so-called r, meaning to say the radius vector. Then, after knowing the formula, we're going to substitute the value of y is 8 and the value of r is 10, which is the hypotenuse. So that's why the sine theta is 8 over 10. For the cos theta, adjacent or adjacent, from this angle, if this is the opposite, this hypotenuse, so the adjacent is here, the x-axis. So that's why we have x and hypotenuse are the radius vector. So we're going to substitute upon knowing the formula x over r. Our x is 6 and our radius is the hypotenuse. Our cosine theta now is 6 over 10. And for the tangent, we have the formula opposite and adjacent. So this is the opposite and adjacent. So we have 8 and 6. So that's why we have 8 and 6. For the cosecant theta, right, we have to do is just only to reverse. If you know the sign, the cosecant theta is the reverse of 8 over 10. So that's why our cosecant is 10 over 8. We have also the formula right here. And for the secant theta is the reverse of cosine theta. So we have 6 over 10, so the reverse is 10 over 6. And for the tangent theta, we have 8 over 6, and the reverse of this is cotangent theta. So that's why our cotangent theta is 6 over 8. That's our answer for the sixth trigonometric function. Okay, number 19, find the six trigonometric functions where the terminal side of the angle form pass through the point 3 and 4. So this is the coordinate. So our solution, first we have to find out the given. The given is the x is equals to 3. This is the abscissa. And the y, which is the ordinate, is 4. And the radius vector is not given. So we have to compute for the radius vector before we can find the sixth trigonometric function. So our formula is radius vector r squared is equals to x squared, the ordinate, and plus y, this is the abscissa, and the y is the ordinate squared. Then we're going to substitute. The x is 3 squared plus the y is 4 squared. 3 times 3 equals 9, 4 times 4 equals 16, 9 plus 16 equals 25, r squared is equals to r squared equals to 25. Then we're going to find the square root of both sides, so we have now r equals to square root of 25. Our r now, the radius vector, is equals to positive or negative 5. So our answer for the six trigonometric functions, we have sine theta is equals to y over r. So y is given is 4 and the radius vector is 5. So that's why our sine theta is 4 over 5. For the cos theta, we have x over r. So our x is 3 and our radius vector, the hypotenuse is 5. So 3 over 5. And our tangent theta is equals to y over x. Our y is 4 and our x is 3. That's why we have 4 over 3. Since we know the sine, cos, and tangent theta, so the cosecant is the reverse of sine. The reverse of sine theta is 4 over 5. That's why the cosecant theta is 5 over 4. And for the secant theta, the reverse of cos theta is equals to 3 over 5. It becomes now 5 over 3. And for the cotangent, the reverse is tangent theta. We have now 4 over 3. It becomes now 3 over 4. So these are the six trigonometric functions. This will be our final answer.